Alright, so today's problem is going to be longest consecutive sequence. Let's have a look. Given an array of integer nums, okay, return the length of the longest consecutive sequence of elements that can be formed. Okay, what is a longest consecutive sequence? A consecutive sequence is a sequence of elements in which each element is exactly one greater than the previous element. The elements do not have to be consecutive in the original array. Alright, so let's have a look at the example so we can get a better understanding. So for example 1, you have something like this, and then the output is 4. So why is it 4? Well, a sequence is basically a series of elements where each element is exactly 1 greater than the previous element. You see, 3 is larger than 2 by exactly 1, 4 is larger than 3 by exactly 1, and 5 is larger than 4 by exactly 1. Oh, there's another 4 here, but it doesn't really matter. Duplicates don't do anything. So this is the longest sequence that we have here. Also, what other sequences do you notice? Well, another sequence that we see, besides 2, 3, 4, 5, I see a 20. This is also a sequence, but there's no 21. If there's a 21, then it'd be 20, 21, but this is its own sequence. It's one element, right? And 10 here is also its own sequence. It's a sequence with length of 1. So you can imagine that if we somehow get a hold of this, and if we can identify all the sequences, we can just take the length of the longest one, and then that'll be our answer. So how do we get here? I think something that I want you to pay attention to is that we don't have a sequence that's like this. We don't have a 4, 5. We don't have a just the number 3 or just the number 4. And that's because these things are not really sequences. They're more like, I think of them more like subsequences. You know, they're like 3, 4, and 5. They're like 4, 5, 3, 4, 5, 3, 4, like any combination of these. They're all a part of this one big sequence. Like, why would you count this if it's part of a larger thing? You know, that's how I see it. I brought it up because this is something that we do intuitively. Like, we didn't even really end up thinking about it. But I think it'll give us a hint in how we're going to solve this. If we were to inspect our intuition a little bit more deeply, how do we know that 3, 4, 5 is part of a larger sequence? How do we know that 2 is not part of a larger sequence? How do we know 3 is part of a larger sequence, or 4 or 5 is? Well, let's have a look at the number 3 here. We can say that number 3 is part of a larger sequence because there exists a number inside our input list that is 1 smaller than 3, right? And you can say the same thing about 4 as well. There exists a number inside this thing that is 1 smaller than it, and for 5 as well. But for 2, what makes 2 special is because we don't have a number that is 1 smaller than 2. In other words, we don't have the number 1 inside our list here. So if we're able to identify which number doesn't have a number that's 1 smaller than it, then we can safely conclude that it's going to be a sequence starter, right? And well, we pretty much intuitively identified the number 20 and the number 10 the same way. There is no 19 here, so this is a sequence starter, and there's no 9 here, so 10 is also a sequence starter. That's how we came up with these things. So let's say hypothetically, we're able to identify all of the sequence starters, like here, like so. Now what are we supposed to do with this? Well, now it's pretty easy, right? Since we know that this is a starter, well, there might be an element after 2, right? So let's look for a number that's 1 larger than 2. So we can try to find 3 in here. And then once we have 3, we can say, okay, that 3 might not be the end. There might be more. Let's go look for more. Is there a 4? Yep, there's a 4. All right, this might not be the end. There might be a 5. Let's look for a 5. Yep, there's a 5. And then, is there a 6? There's no 6. So we've completed our sequence here. So the longest sequence we have so far is 4. All right, then we can repeat the same process for the other sequence starters. Let's have a look at 20. Is there a 21 here? Nope. Okay, so unfortunately, this is the end. So this is length 1. We can check whether 1 is bigger than 4. It's not, so it doesn't replace longest. And same story here. There's no 11, so the length of the sequence is 1, and it's not larger than 4. So this is going to be the length of our longest sequence. The same as our output, right? So theoretically, that kind of works, right? But technically, will this be an efficient solution? Well, let's have a look then. So the first step is to identify all the sequence starters. So how are we going to do that? Well, let's just loop through it. Easy. For num in nums, all right? So as we discussed earlier, if num minus 1 not in nums, then we know that num is a sequence starter because there's no number before it. So let's say this if clause is true. We've identified it. So then what do? Then we gotta save it. Let's make a little list called sequence starters. It's just empty in the beginning. And then so if we've identified one, then we can just append it here. Well, I'm just gonna name it starters, so it's a little bit shorter. Starters. Append num. Cool. Otherwise, if it's not a sequence starter, then whatever, we ignore it, right? All right, that's cool, that's cool. Now, I'm already kind of seeing a problem here. The problem is with this line, because if I'm going to be looking for a value inside of a list, we know that what Python's going to do is that it's going to scan the values one by one. And if we're doing that n times, then this loop alone is O of n squared, which we don't like. There's a really easy way to speed up lookup speed, and that is to use a hash map. So let's do that. I'm going to define, well, instead of a hash map, I'm going to be using a set, because I don't think I really need the key value pair. It's a little bit overkill. If I need it, I'll add it, but for now, let's just stick with a set. So I'm going to call this set nums, and this is basically just passing nums into the sets function, which will turn this into this basically. Yeah. So rewriting this a little bit. So instead of trying to find it in the list, I'm going to try and find it in our set, in set nums. Now this is much better. This is going to be O of 1. This is O of 1. And we run those O of 1 operations n times. So it's an O of n loop. That's really nice. So once we got that, let's go through every starter and see how long each starter sequence is. For starter, in starters, well, before that, we kind of have to keep track of how long the longest sequence is so far. So let's have a variable that holds that. Longest sequence starts at 0 because we don't have anything yet. So what I'm going to do is, well, initially the sequence is going to be length of 1, right? Because if we have the starter, then it's automatically at least 1. And then I'm going to say the next value, the next is going to represent the value that comes after the starter, right? So that's going to be starter plus 1. So let's say the starter is 2, the next is going to be 3. So that's the setup done. I want to keep looping, and I want to keep going so long as there is a next. So long as there's a next in the set nums. Hey, look, it's another lookup that we're doing several times that we optimized by using a set. Very cool. Very time efficient. So what's going to happen if we found one? So let's say we're doing 2, and then it runs this, and then it finds a 3. Oh, there's a 3 in the set. Cool. What do? Then of course, if we found 3 in the set, then our sequence is 2 and 3, right? So we can say the sequence is plus equal 1. So now we have 2 elements in our sequence. And then we have to increment next by 1, because next time we're going to be looking for 4. All right, so let's try to look for 4 then. So this runs again, is 4 in here, yes. And then sequence goes up by 1, because we have 3 elements now. And then we'll increment that, we'll look for 5. We found a 5. Now we have 4 elements, and sequence becomes 4. All right, neat. And then we'll try to find a 6, and then we'll realize that there is no 6 in here. Well, technically there's no 6 in here. And that's it, we're done. The length of this sequence is 4. And then we have to update our longest sequence variable. And that's going to be the max, whatever's larger, between the sequence we have so far and the longest sequence that we've recorded so far. And that's pretty much it. We just kind of return this at the end. That's kind of done, right? Wait, no, we're not done yet. And then we're going to repeat this loop for the others. Let's say next is 20. All right, sequence is 1 for 20. And then we're looking for 21. 21 doesn't exist here. So this while loop doesn't even execute. And then it will try to update it, but 4 is clearly larger. And same thing with 10. Yeah? All right, that's it. I've pretty much written out the code line by line here, but let's just do the same thing in the editor. So this is the code. Whatever we had on the whiteboard, I just kind of wrote it all out. Let's give it a run. Yay, it works. Before we close up, let's have a look at the time and space complexity of this real quick. So with this, we have creating the set is going to take O of n time, because we're going to loop through each element of nums, and then we're going to put that into a set. And this is O of 1, and then let's have a look at this, where it's more interesting. We have a loop, a for loop, that's going to execute for each number, so this is going to be O of n. And what about the operations in here? This is going to be a set lookup, which is O of 1. This is an append, which is also O of 1. Because of how we've constructed this code, we're actually only going to be touching each number at most once. The only reason we would touch a number multiple times is if our code is bad, and then we started counting the subsequences as well as the main sequence, the bigger sequence that it's a part of. And because we only care about the largest possible sequence, then we're only going to be touching each number once. So if we're only going to be touching each number once, then this is an O of n operation. So the time complexity is if you add all of this up, O of n, O of n, O of n, so basically linear time, right? And for the space complexity, the set is going to be as large as nums, which is O of n, sequence starters in the worst case scenario, where every single number are sequence starters, then this is going to be O of n. So O of 2 and then space complexity, effectively linear. And that's it. Okay, bye.